Today we will look at work and energy, and the question we have reads: a bulb of mass 15 kilograms is suspended using a string of 4 meters long from a support and swung through a vertical height of 1.2 meters as shown. So the diagram is as shown. Roman 1, determine the potential energy of the bulb at its position, so that is at 1.2 meters height. Roman 2, the speed of the bulb when passing through the lowest point during the swing. So for Roman 1, we are required to get the potential energy of the bulb. So the potential energy, remember, the bulb was swung from the original position. So originally it was hanging at this point, and then it is swung to a height of 1.2 meters. So as it rises from this lowest point to this height, it is gaining some potential energy, and the potential energy, which I'll represent by PE, is just work done in raising the bulb to a height of 1.2 meters. So work done is given by the force required by the distance covered, so that is a product, and that is given again by, so the force is just the weight of the bulb, which is given by mg, and the distance covered is the height h. So doing our substitution, we will get the mass we already have as 15 kilograms, so that is 15 times g is the gravitational acceleration. So the gravitational acceleration of the earth we know is 10, so we're assuming it's 10 meters per square seconds. And then the height through which the bulb was raised is 1.2 meters, so we have times 1.2 meters. This worked out should be 180 joules. Remember, it's energy, so energy is expressed in joules. Now once we've gotten that, the next question requires us to get the speed of the bulb when passing through the lowest point during the swing. So the moment we have raised the bulb up to this height, definitely it will be oscillating to and fro. So from this height, as it moves back to the lowest point, then the potential energy converts into kinetic energy. So by the time it gets to the lowest point, all the potential energies has converted into kinetic energy. So we will say that at the lowest point, the potential energy is equivalent to the kinetic energy. And we know that kinetic energy is given by the formula a half times the mass times the velocity squared. So already we know that the potential energy in this part is 180 joules, and that is equivalent to the kinetic energy. So we have a half mv squared is equal to 180. We know that the mass of the bulb is 15 kilograms, so we do the substitution. We have a half times 15 times v squared is equal to 180. So that means v squared is equal to 180 times 2 over 15, and that therefore means v squared is 24. And from this, when we get the square root, v is equal to the square root of 24, and that is 4.8989. So that is 4.899 meters per second. So that is it for this question. Thank you for your patience. Thank you for watching. See you in the next video.